This is the second video of topic 12, and we're going to look at using integration for various things such as areas and volumes. We could find the area under the curve by dividing it into lots of little parts. And then turning them into rectangles, and then finding the area of the rectangles. But it would be inaccurate at most. We'd have to make the rectangles tiny, tiny and very skinny. So what we use is we actually use integration, and using integration we can find that the area is the integral between our points A and B of whatever the function is. Now, this only works if our area is above the x-axis. If we've got anything below the x-axis, then we have a problem. So what we need to do is we need to draw a quick sketch of anything that we're doing and check that we haven't got something that's underneath the x-axis, because the area underneath the x-axis actually flicks up as a negative number, and it obviously cancels out some of the area on the top. To find the area under here, area is equal to, in this case, the integral between 5 and 2 of x squared. Now we check our diagram. All of the graph is above the x-axis, so we don't have a problem. So we just need to then do some definite integration. The integral of x squared is x cubed over 3 between 5 and 2. Substitute them in, do the subtraction, and we get our answer of 39 square units. Have a look closely at this diagram. Suppose we're trying to find the area between x equals -1 and x equals 1. Now, if we just find the integral, and our function is x cubed, and that's x to the 4 over 4 between 1 and -1, and if we number crunch that, put in 1, put in -1, we get our answer as being 0. Now clearly that is wrong, because clearly there is area. You can see it, it's shaded blue. So what went wrong? What went wrong was we ignored the fact that part of our area was actually below the x-axis, and in this case, because it's symmetric, it was completely cancelling out the area that's above the x-axis. So what we have to do is we need to break it up into little bits. We have to, and this is why we need to draw a graph, we need to see what is under the x-axis and what's not. So what we need to do now is say that the area is equal to, the bit above the x-axis is fine, so between 0 and 1, there's no problem. But what we do is we just take the absolute value of the bit that's below. So it's below the x-axis between -1 and 0. And now we've turned the right-hand term into a positive number, which it is, it's an area. Now when we do the calculations, we get 1/4 plus 1/4, which is 1/2, and that's more sensible in terms of the area. This question relies on us finding K first. So PV is equal to K, and V is 2, and P is 250. So K is 500. And then also we need to actually, because the formula requires us to find P and we have PV equals K, we need to rearrange that so that we have P is equal to K over V. Now we're ready to integrate, and we can integrate so that the work done is the integral. Now what's it between 1 and 4, and P is K over V, which is 500 over V, and we can integrate that. It's a natural log of V, plug in 4, plug in 1, subtract, and our final answer then would be 693 kilojoules. This is a similar but slightly different integration. Again, you're finding the work done, and it tells you that the work done is the integral between the two x values, so that's between 0 and 1 of the function. So what would we find? We'd find that that's equal to -4 over pi cos pi by 2x plus 6 over pi sine pi by 2x. And our two limits are 1 and 0. That stage it's a calculator job. And 1.9. Give it a unit. To find the area between two curves, what we do is we find the area under the first curve, the top curve. So that one there is our top curve. So that will give us all of this area here. Let's just draw it again over here. So if we find the area underneath the top curve, it gives us that. And then if we find the area underneath the bottom curve, it's going to give us that. And then what we've got left is the area between the curves, like that. So it's the blue shaded area that we want. So our process then is to find the integral, find the area under the top curve, and we just find the integral of that between the two limits, and subtract from that the integral under the bottom curve, the area under the bottom curve between the two limits. The big thing for these sort of questions, and there will be one in every exam, is to check that you have the limits. Now in this question it's quite clear that you're given what the limits are going to be, because it shows you where the two curves intersect. If you haven't been given the intersections of the two curves, then as part of the question you will need to find them. In this case we're given them, so we can just proceed. So the area is going to be the area under the top curve. Now your top curve is the straight line. Sometimes you're not even told that, so you need to do a diagram. So it'll be the area between -3 and 2 underneath 7 minus x, and then from that you're going to subtract the integral, same limits. The other curve is x squared plus 1. And you can actually combine those two. And I'll carry on as if I have combined them, so it'd be the integral of 6x minus x squared over 2 minus x cubed over 3 between 2 and negative 3. Put a 3 calculator, 20 and 0.8, 20.8.